Hi guys, welcome to engineering chemistry class, lesson 7, corrosion control methods. So today we are going to learn about the corrosion control methods by any two methods like proper designing and cathodic protection method. So how to control corrosion by proper designing of a metal. Proper designing of metal or proper designing of any equipment. So first and foremost point is avoid contact of two different metals. When two dissimilar metals are in contact, the anodic part should possess larger surface area than the cathodic part. When the two metals are in contact, they should be close with each other in galvanic series. In the last class, I have displayed the galvanic series of metals. So from this metal, we can find out how many metals are in close contact. What are the metals they are in close contact with each other. So the anodic part should be properly coated. If not, it corrodes more than without painting. So the design of the equipment should allow free circulation of air. The design should eliminate sharp corners and stresses. Modification of poor design. And corrosion control by cathodic protection method. What is cathodic protection? That is, the metal to be protected is forced to behave like a cathode. Therefore, it prevents the corrosion. Therefore, the corrosion will not occur. That is called cathodic protection. So, there are two methods in cathodic protection. They are sacrificial anodic protection method and impressed current cathodic protection method. First, let us discuss about sacrificial anodic protection method. So, you see this diagram. Pause this video for a while and you look at the picture. Then coming to this point. In this method, the metallic structure to be protected is connected by a wire to a more anodic metal so that the concentration is concentrated at the more active metal, implies the more active metal itself gets corroded. See, if you want to protect the pipeline, it should be connected. It should be forced to behave as a cathode so that this metal should be connected to the more active metal. If the pipeline is made of iron, it should be connected to the more active metal like magnesium or zinc or aluminum, so that all the corrosion concentrated on the active metal. Okay. So while the parent structure, which is cathode, is protected, the more active metal so employed is called as sacrificial anodic. Whenever the sacrificial anode is consumed completely, it is replaced by a fresh one, and the metal commonly employed as sacrificial anodes are magnesium, zinc, aluminum and their alloys. Sacrificial anodes are used for the protection of buried pipelines, underground cables, marine structures, ship hulls, water tanks, etc. And coming to the second type of cathodic protection method, that is impressed current cathodic protection method. Look at this picture. Pause this video. Look at this picture. Next, in this method, an impressed current is applied in the opposite direction to nullify the corrosion current. See, whenever there is a two metal, one metal acts as anode and another metal acts as a cathode, and if there is an electrolyte, you can say water or moisture, a cell will be created. So when two metals are there in presence of electrolyte, it creates a cell. So same way, in corrosion also, if anodic area is there, cathodic area is there. When two different metals are there, one metal will become anode, one metal will become cathode, and in presence of moisture, if corrosion takes place, then we call it as corrosion current. In cell, electric current will be we will get, and if corrosion occurs, we will call it as corrosion current. So in this method, an impressed current is applied in the opposite direction to nullify the corrosion current, and the corroding metal from anode, and the current flow through the corroding metal from anode to the cathode. Usually, the impressed current is derived from a direct current source like battery or rectifier on AC line without an insoluble anode like graphite, high silica iron, scrap iron, stainless steel, or platinum. Usually, a sufficient DC is applied to an insoluble anode buried in the soil and connected to the metallic structure to be protected. The anode is buried in a backfill such as coke breeze or gypsum to increase the electrical contact between itself and the surrounding soil. So the applications of impressed current Cathodic method are: it is used in buried structures like tanks, pipelines, transmission line towers, marine pipes, laid up ships, etc. The advantage of this method is they can be automatically controlled, which reduce maintenance and operational costs. Pause this video for a while and go through the difference between the sacrificial anodic method and the impressed current Cathodic method. I hope you understand this topic. Thank you for watching.